Hello students, Miss Slyman here, and we're going to talk about recursive sequences now. Recursive is just another way of defining a sequence instead of the explicit formula. We can have a recursive formula. So let's go ahead and look and see what that means. So we've got a linear sequence, 4, 7, 10, 13. We also normally call that arithmetic. Without writing out the general formula, I see we're going up by 3 each time, so the next 3 terms, those are going to be 16, 19, and 22. So what did we do to the previous term to get the next term? Well, we added 3. So if T1 is 4, so here I'm using T as my sequence, T1 is 4, I could say that T2 is T1 plus 3. An expression for T3 in terms of T2, well, to get the third term, I take the second term and I add 3. So an expression for Tn in terms of Tn minus 1. Notice here we had T3, 3 minus 1 is 2. So what we're saying is that each term can be thought of as the previous term, so t to the n minus 1 is the previous term plus 3. And this version is the recursive formula. I'm just going to get rid of that line there. So recursive means that we have to know a previous term to figure out the next term. So here the recursion formula, Tn equals Tn minus 1 plus 3, but we have to know that the first term is 4. So the recursion formula is not so useful because it says that I have to know the previous term to know the next term. So if I asked you for the 100th term, you would have to know the 99th term. But it's useful for ones that I can't define arithmetically or geometrically. So here would be our recursion formula for this sequence, and since it's arithmetic, here would be the explicit formula. So that's a brief introduction. I'm going to come back with the next video for example 1.